Swayam Prabha. Digital India. Educated India.
Hello everyone. So, now we have reached almost at the end of our course, the last module we are discussing. Now, in the friction spinning, we will try to understand the friction spinning yarn formation, okay, and how the twist is imparted, and we will try to discuss this aspect with a simplified diagram, okay, just for the basic understanding. Now, the yarn formation, if you see here, this is the friction drum here, this is the spinning drum, and this figure illustrates the spinning drum, okay, are longer than the width of the fiber feed. So, this is the spinning drum, and width of the fiber feed is shown here as zone 1, but the friction drum length is more than that. So, zone 1 length and zone 2 length consist of the friction drum. Okay. So, that means the fibers are feeding on the friction drum, not in the whole width, because this width, this length of the friction drum is used for final application of twist, that we will discuss. And we have in this design, in this diagram, we have shown the 4 slivers are fed. So, the leftmost is 1, then 2, 3, 4, and 4th sliver is fed, which is closer to the withdrawal, it is towards the withdrawal direction. Now, the thing is that when we see the yarn cross section, that means the 4th fibers from 4th sliver are deposited on the 3rd fibers from the 3rd sliver, and whereas the fibers from the 1st sliver form the core portion. So, you can see the diagram here, if we see, and one can see there is a clear demarcation of this system. This core will be from the sliver 1, then the next ring will be from the sliver 2, from the sliver 3, and outermost ring or sheath will be from the sliver 4. This is the ideal distribution, but in actual case there may be some mix up, but clear difference will be there. The yarn formation therefore occurs along the 2 parts of the friction drum. First is the in zone 1, where they are getting twisted, and here the conical formation will be there, because at the leftmost portion the fibers are coming only from the sliver 1, but in the next zone the fibers from sliver 2 is deposited on the sliver 1. So, there will be at the tail there will be conical formation. Zone 1, that is called the fiber supply zone, okay, and the second zone is called yarn forming zone. Okay. So, there forming of yarn receive no more fiber. So, here mainly yarn forming zone, here there is no fibers are additional fibers, that is why it is shown in parallel as a cylinder. So, that means zone 1, the fiber feed zone, that is yarn tail becomes the tapered yarn tail. The fiber landing onto the friction drum in the zone 1, that is from the conical yarn end or tail between the drums. Now, you can see from the figure A, the fibers from the opening roller through the transport channel, it is falling on the nip of the spinning drum. So, fibers travelling from the opening roller to the friction drum, that is that friction drum is there, and then figure 2, figure B shows the fibers landing and being twisted to form yarn. So, here the fibers are being twisted, okay, due to the rotation of the friction drum. The fibers are individually twisted onto the conical yarn tail. So, there will be conical yarn tail formation during this deposition, and the formation of drape 2 yarn structure is therefore a build up of layers of fibers, okay, from the sliver. Okay. Now, here again, so layers of fibers are there. So, it is evident that any migration between the layers is very small. So, there is a, although some little migration may take place, but the migration, chances of migration is very small, okay, that the yarn is much more compact in the region of the core. So, at the core region yarn will be compact because the sheath, the next layer from second, third, fourth sliver are wrapped over the core. Since the spinning tension is low, it is unlikely that the compaction is caused by any applied tension. So, there is no applied tension like our ring spinning. So, where the compaction takes place due to the balloon or yarn tension. So, here there is no such tension, only due to the rolling action. So, in zone 1 the twist level is low. So, here the twist level is low and the centrifugal force cause the yarn to swell. So, there is a centrifugal force. So, and the twist in Z2 zone 2 is much greater. So, here is actual twisting will be there because in that it is positively that in the zone 1 the twist is less, much greater, and the diameter decreases in this zone due to the high twist, okay. And here the twist is less in zone 1. So, as the yarn leaves the friction drum, the amount of twist in each radial position will depend on the time duration of the fiber in that position stayed within the 2 zones. So, what is the time when the yarn take up direction is along the yarn drum axis. So, how much time they are staying on the drum surface, that will decide the level of twist. This is because the twist gained is cumulative between the point where the fibers land and the at the end of the friction drum. This means that the fibers forming the yarn core are highly twisted. So, here at the core, because this is actually the core fibers at from the one sliver, which is staying on the yarn surface at the longer time. in drape to spinning, the individual fibers are blown off the opening roller, and during transmission, during the transport, they gets buckled. Okay, they have become buckled. On landing and during the twisting of fibers, they are hooked, folded, entangled, and with a looped configuration. So, they come in random fashion. So, Lord and Rust studied the fiber assembly in friction spinning and proposed that there can be two methods of assembling into the fiber into the sheath. So, these are the two methods. The methods are, one way is that the fibers assembly completely on the perforated drum before they are transferred to the rotating sheath. Okay. And second one, the other is that the fibers are laid directly onto the rotating sheath. So, they have proposed this. If the surface of the sheath were smooth, the centrifugal force would throw away the fibers from the surface. So, the surface cannot be smooth here, because the centrifugal force was there. So, that is why due to centrifugal force fiber will come out. The nature of transfer is influenced by the surface of the sheath. Okay. And thus that because if this surface, yarn surface, whatever the core, the surface, if the surface is smooth, the next fiber which is falling, they will be simply thrown out due to the centrifugal force. So, the nature of the rotating surface, okay, it is a non-smooth to retain the incoming fiber. So, this is the, if there is some hairs, they will try to attract the fiber. So, they should not be very smooth. So, fiber captured by the sheath is the fiber ends and other protruding fibers from the surface of the sheath. So, like this type of protruding fibers, okay, form hairs, and that stand out quite rigidly from the surface when the sheath rotates. So, and the surface of the sheath would rather be like a card clothing. So, this will be like a card clothing which attract the fiber which is coming from the opening roller. Now, A in this picture, so ingoing fibers approaching entrapment. So, A is the ingoing fiber which is approaching the entrapment, E here is hair. So, as we have discussed, the hair should be there, that will actually attract the fiber, here attached to the rotating sheath, S rotating sheath, and R ingoing perforated drum. So, this is the ingoing perforated drum, and now an arriving fiber can easily become trapped as the hair is folded back. So, this they will be easily trapped, the hair will get folded at the this ingoing perforated drum. So, they will be trapped in between the hair, okay, and the new fiber continue to be trapped. So, in this way the fibers will continue to be trapped, and you can see these fibers in the hair, as the hair folded, new fiber came and they are trapped inside the structure. So, these are the different stages. So, ingoing fiber meshing with the hair, the ingoing fiber is meshing with the hair, and commencement of entrapment is there. So, they are getting entrapped, continuation of entrapment, this fibers is entrapped here, and we can see release of fiber from the entrapment. So, they are and de-entrapment of fiber. So, they are sometimes if they release from the fibers from entrapment, and the next hair will again entrap this. So, this is the way the fiber entrapment take place. If the time of entrapment is less than the time before the hair bends back again by the nip of the nip between the sheath and the outgoing, this is the outgoing torque roller, and here is the incoming torque roller. Then the fibers will move and become a hair itself. Okay. The hair tends to grow in length at each release point. After few episodes of entrapment, the new fibers become locked in place, and there exists a great deal of fiber migration. So, here the fiber migration will be there in the sheath due to the entrapment of the fibers. The probability of fiber capture is a function of the, you can see the total number of capture site, loop or protruding fibers, the probability P1, which is the function of the length of the fiber assembly zone, small l length of the fiber, longer the fiber, higher will be the probability, velocity of the fiber, rho is the density of the fiber, angle of descent. It has been stated that the perpendicular fibers which is approaching at 90 degree, the capture efficiency will be virtually 100%. So, the fibers which are coming vertically, they are actually that capture efficiency will be 100%, but the main problem will be that the fiber extent. So, like in drape 2, the capture efficiency will be high, but fiber extent is very poor, which actually forms a weaker yarn. When the alpha is reduced, fiber extent improves, but capture efficiency is less than 100%. So, fiber supply, so in case of the drape 5 system, the yarn tail can be considered as loosely constructed conical mass of fibers formed at the nip of the friction drum, that we have already discussed. This is the loosely formed conical mass, that is the yarn tail. In spite of very porous lofty structure of fibers, they are rotating at very high speed. Okay. Now, the twist insertion in the open end friction spinning, how is it the twist is getting inserted at the tail end. Okay. Now, here consider one fiber, this fiber is shown by A, B, C, D. Okay. This is the fiber, this figure represents fiber being applied to the open end. Okay. This is the open end of the yarn of the friction spinning. Okay. This is the fiber, and fiber such as those shown in the position A, B, C, D, E rotates about the conical end. So, these fibers at different position the rotates about the conical end of the yarn. X y, this is the yarn, x y z is the yarn. So, y z is the conical portion. The fiber may be anchored at D, this is the point where fiber is anchored. So, now if you see, this is the yarn x y z. Okay. Now, a single fiber, now this is the way, this is the point, the anchoring point D. Okay. The resultant structure will consist of the fiber A, B, C, D, E being laid roughly on the conical surface. This is the conical surface, okay, and this is laid roughly on that, and A point A being not attached with the conical end, yarn end. Now, the fiber ABCD may or may not end up at the perfect spiral. Okay. Furthermore, the geometry of the cone XY may change with the time. So, this cone geometry will change with the time and the spinning condition, that we will discuss gradually in the next section. Now, the fibers arriving in the spinning zone are carried into the mesh, okay, with the yarn tail being the open in the spinning drum. So, the yarn tail is the open, so X, the tail is open. This envelops the fiber at the open end. So, this fiber will try to rotate around this open end and then getting twisted. The fibers near the tip of the loosely wrapped, okay, near the tip are loosely wrapped around the yarn tail. So, this fiber which is anchored at D, point D, this is anchored at point D, will be loosely wrapped around the yarn end, where those away from the tip are progressively more tightly wrapped. Okay. So, here they will be more tightly wrapped. Now, the condition will be like this. This is point D, they will be wrapped tightly, and at the A it will be loosely wrapped. Okay, at the now, we can see in the core type friction spinning in drape 3, the core made of filament or bundle of staple fiber, the staple yarn is false twisted. Okay. So, as I have already mentioned, in the core spinning, the core portion is false twisted by the spinning drum, the sheaths are deposited on the false twisted core structure and then wrapped helically over the core. And there are different researchers, they believe that the false twist in the core was removed once they emerged from the drum. Okay. That is the some study, but there are many other studies, they are being trapped. Okay. So, ideally the core should have been twistless, but actually it has been observed that core is not twistless, and there are some twist remains due to the twist locking by the sheath. However, it is quite possible for certain amount of false twist remain in the core because of the sheath entrapped during the formation of the spinning zone in the spinning zone. So, yarn formation during the yarn formation, the spinning zone, that twist, false twist is trapped. Now, we will try to analyze the twist insertion in the friction spinning at different zones. Now, we consider the yarn twist in the yarn forming zone to be in 5 region. So, we are considering in the 5 different zones. Okay. The zone 1, that is L1 of length L1, which is from the beginning of the friction roller to the beginning of the suction slit. Okay. So, this is the beginning of the friction roller. Okay. Friction roller is the blue color, dark blue color is the friction roller, and the suction slit is starting at this point. So, from this point to this point, beginning of the friction roller to the beginning of the suction slit is L1, and you can see this green color is shown the fiber transport channel, and fiber transport channel is not feeding the fiber to the entire length of the that is the perforated roller. Okay. The suction slit. So, suction slit, within that some portion the fibers are being fed. So, L1 is that zone where it is the beginning of the friction roller to the beginning of the suction slit, zone 1, then zone, this is the zone 1. Now, zone 2, from the beginning of the suction slit to the beginning of the transport channel sheet. So, this is the transport channel sheet. So, where up to which point the fiber will be transported. So, that is L2, it is giving L2. Now, 3, point 3 is the from the beginning of the transport channel slit to the beginning where the yarn diameter becomes equal to the gap. So, gap between the rollers, there is certain gap gamma, and yarn diameter is continuously forming. Okay, yarn is continuously forming. So, yarn diameter 2 r, r is the radius of the yarn, equal to the gamma, that is the distance between the gap, that is a gap between the two terms. So, that zone 3 will be somewhere here, this zone is L1 and L3 and L4. So, zone 3, this is the point where the yarn diameter is equal to the gap between the rollers. And zone 4, where it starts from that portion of the end of the zone 3 to the end of the transport channel. So, end of the transport channel is here. So, at that point R will be 0, the yarn, there is no yarn because no fibers are there. So, from R to R, that is R to 0 at that point. Okay. So, that will be the zone 4, and zone 5 is that end of the transport channel to the end of the this roller, the drum. Okay. And zone 5, the end of the transport channel slit to the end of the friction roller, that this is the zone. that is L5, length of that it is L5. So, this total zone is divided into 5 different zones. Now, we can see this schematic diagram shows the diameter of the yarn. Now, you can see here up to the L2 the yarn diameter is there, this is the yarn diameter. Now, from L2 to L3 the yarn diameter is changing. So, that means it is a growing that way. This is a full yarn diameter and here the yarn diameter is half, that is yarn radius will be there, yarn diameter will be 2r at this point, which is the half of the yarn diameter at this point will be equal to the gap of between the drum, okay, at that point. And after that this L4 where it is a tip formation, at the end of this, that is the starting point, that means R becomes 0. This shows the diagram at the bottom shows the yarn diameter profile and at the top it shows the different zone based on the 5 perforated roller, the drum. It is assumed that the yarn has circular cross section. Okay. The fibers are assembled in the regions 3 and 4. So, in this zone fibers are assembled because the transport channels, the width is at that zone, the fibers are actually deposited within that zone. The yarn in the region 2, 3, 4, that is 2, 3, 4 is subjected to the suction air pressure, because the suction slit is up to 2. So, here in this zone 2, 3, 4 there will be the yarn will be subjected to pressure, okay, in this zone, because thus it is yarn is under control of the suction air pressure. In region 5, so in region 5 this is the region where for drape 2 or only friction spinning yarn, drape 2 type friction spinning yarn, there is nothing, but in core spun filament core sheath type of friction spinning, here core filaments will be there, okay, core filament or any coarse yarn, that is for drape 3. This section 5 is valid for only drape 3 type of spinning. The yarn leaving the region 1, that is the region 1, okay, is not in contact with the rotating roller. So, here that is why it is the yarn comes out from the this rotating roller, because there is no torque, because it immediately it will come out, it is because suction is not there. Theoretically in region 4 and 5, so and region 4 and 5, so in between this zone of the yarn or filament diameter is less than the gap between the friction roller, that we have already discussed. So, at 3 the yarn diameter is equal to 2r equal to gap, okay, but between 4 and 5, 5 is only for the filament. So, at 4 zone 4 for drape 2 type friction spinning yarn, that open end friction, the diameter is less than the gap. So, there is not much friction, okay, frictional action is not taking, or both the rollers are not coming into picture. Therefore, there is insufficient contact because the yarn diameter is less than the gap. So, contact, and they are not in contact simultaneously with the both the rollers. Maybe there they will be contact any of the rollers at a time. Hence, the amount of twist insertion in this zone is very low, because they are not been twisted by the frictional contact. And the from the stroboscopic observation, no visible change in filament twist is there. So, in case of coarse spinning, there is no change in friction twist in this region. So, from point x3 to x2, okay, the yarn is in contact. So, x3 here, where diameter of yarn is equal to the gap, and to the x2, this is the x2 zone, these are that they are in contact with the both the friction rollers, and torque is basically applied in that zone, yarn tail. So, in yarn tail, although this is the yarn tail, but basic torque is applied here in this zone, where the yarns are in contact with both the drums or both the rollers. Although there is a great deal of relative torque between the point x3 and before it, okay, x3, this is the x3 and before it, apparently great number of twists are inserted in the yarn or filament at this point. So, that is the point. The yarn in the region 3 is contact with the equivalent friction rollers. So, that is this they are in contact, and most of the twist seems to be inserted in this region. The length, because of the fact they at this zone, what happened, the number of fibers are minimum, and they that zone, at this zone the fibers are, the yarn is in contact with the both the rollers. So, torque is less and the frictional force is high. So, that makes the fact that the in this region twist is inserted, most of the twist is inserted. The length in this region varies for various yarn diameter. Okay. Now, this is the condition L3 equal to x4 minus x3 multiplied by R0 minus gamma by 2 divided by R0, where R0, the diameter radius of the yarn, is more than equal to gamma by 2. R0 is the radius of yarn and gamma is the friction, that is gap between the friction. R0 is the its variable. So, at any point yarn radius, the yarn diameter or the yarn count plays an important role in the friction spinning, twist insertion. The yarn in the region 2 in contact with both the friction rollers. Since the yarn diameter in this region is approximately constant. So, here in this region the yarn diameter will be approximately constant, because the yarn has already been built and there is no relative torque along this region, and the twist added to the yarn is insignificant. So, the almost maximum twist, the optimum twist is inserted,